Hello and welcome to another tutorial. We're going to continue our discussion on methods and how to invoke them, what are the properties and what things to consider when we're trying to invoke a method. And we said that methods, sometimes we want to pass a variable number of arguments to a method at the time we call it on an object. And obviously a method has to be written first in the source code, and Java is a statically typed language, and we know that the parameters are part of the signature of the method, so it has to be deterministic, i.e. the Java compiler needs to know how many parameters the method takes, right? And we said that the way we go around this limitation is to pass arrays of same type. I mean, arrays have the limitation that it has to be of the same type, and obviously the size should be known. And then we said that the difficulty with this notation of passing an array is obviously the main limitation now is that the type of all the elements in the array are going to be the same. The way we circumvent this limitation is to pass an object array to it, because object is a superclass of anything. Then we can pass any type to it, even if it's a primitive. I believe the auto boxing can happen. We will try that later. But so in order to circumvent the limitation of the number of parameters, we define the arguments or the parameter of the method to be of the type of array. It could be a primitive array or object array, like some type, class type array, or even interface, right? Any type is allowed. You can create any array, built-in array in the JVM based on any type. And then we said that the problem with this is that people have to create the array outside and then pass it in, or do a in-place array definition using the new this syntax, right? So we should either, and that is a little bit ugly or inconvenient. So what the JDK provides, or what Java provides, is a simple syntax, or basically a syntactic sugar. The way we put it is, instead of saying the point square brackets for the array, we say point dot dot dot. And what this means is that at compile time, the compiler convert this notation to an array. So a method that takes point dot dot and a method that takes point array, they pretty much have the same signature. But behind the scenes, what happens is that if somebody calls this method, right, and then when Java compiler compiles their code, it adds an extra code in the bytecode, so that convert this comma separated list to an array beforehand, and then passing that array to this method, right? So the method signature is going to be exactly the same, but then it's a easier syntax for somebody who writes the source code and wants to call this, because then they can use the comma. You can call the method with a comma separated list of elements. Obviously all these have to have the same type, right? And we saw that implicit conversions don't happen. So if I if I pass some object here, it's not going to implicitly call the to a string. We know that every object, it can be converted to a string, but it's not an implicit conversion in this case. And we saw that when this happens, when the compiler hits this line, what happens here is that before invoking this method, the compiler first converts this comma separated list of elements into an array. And then initializes the elements, right? And we saw the explicit basically the syntax that happens. Basically what does the compiler translates this code, these elements, into exactly this, an array with some undefined name, and then basically initializer list. So it creates an empty array first with 3 elements and then initializes them exactly. And again, the name of the variables don't matter in the bytecode, right? That's why the compiler is able to do this. If the names of the compiler, if the name of variables also mattered in the bytecode, then the compiler has to generate some unique name, and that could cause some problem. But because the name doesn't matter, the compiler can easily do this kind of array initialization or array creations behind the scenes, right? So this variable arguments just makes the syntax easier for somebody who uses the code, but then the compiler does some extra work to make it happen, right? It's just a syntactic sugar. Now the parameter names, obviously Java is, one of the philosophies of Java is that the code has to be very readable. So the code readability, and the idea is that use even if you have to basically write long names for variables, method names, write names that are very useful to understand what they're doing. We saw that, for example, for methods, if a method return type is a Boolean, usually it's testing for some condition. So, and usually the name starts with is or has. For example, is something, right? If you want to check an integer number is even or odd, you can have a method is even or is odd. Or if you want to check if an object has some property, you can say has something or has this property. So a method that starts with has or is, it means it immediately tells the whoever uses this method that it's going to return a Boolean, right? When you declare a parameter to a method or constructor, you provide a name for that parameter. This name is used within the method body to refer to the passing arguments, right? Again, you try to always use nice names. Now, usually we explicitly write the entire name. For example, we could say in this method point dot dot corners. Corners means obviously if it's a polygon, these are the points. This is an array that has all the points of basically coordinates of all the corners of this polygon. So the name immediately tells you. Now the name, again, in the bytecode, it doesn't matter. People who use your library, they use the compiled code, the bytecode. So again, they don't directly see the names, but then if you attach the Java doc, and we will look at how to generate the Java doc as a compressed file, which is jar file, and then you can attach it and your IDE can show you Java doc. For example, if I hover my mouse over this string, it shows me the Java doc, right? And then it also then basically if we look at the method print names, for example, right now this method doesn't have a Java doc. So if I try to go there and then try to create a Java doc, so /* asterisk and then you can document actually the name of the parameters. And again, that's because in the bytecode there is no mention of the name of this parameter, right? Instead, you can directly document it an array of string elements, right? So you can document the name of the parameters, and then if I now hover my mouse over this method, it can basically, why is it not showing the all right, so we have to probably write something. This method just prints something to the console. Let's save it. So this is a description of the method, and then if we hover our mouse here, now it shows me the Java documentation and also the name of the parameters, right? So the parameters is the name. Again, arguments are what you pass when you call the method, invoke it on some object. But the parameter is when you actually, parameters are placeholders, right? When you declare the method itself. And then it tells me the parameter is the names, right? And then it also in the source code tells me a string dot dot dot. So I guess it works right now. Now it shows me that the parameter name is parameter is names. It shows it in the bold font, and then this is the description that I put here, right? So you can also add a colon or something here between them, and then it tells me an array of string elements. So you can explicitly document this. We will definitely come back to the Java doc tool, and I'll walk you through the best practices of how to document your source code. And basically the idea is that every public member, field, or method in your class should be documented, right? All the public API should be nicely documented. And sometimes people even add like example codes on how to use this method, how to invoke it. But usually it's discouraged to actually put example code in your Java doc. The idea is, the best practice, to give a nice description and then list the name of the parameters that were used in the source code, and then eventually the return type. So if the return type of a method is not void, then you can also say @return, and then say that void returns nothing. So if I hover my mouse, it says that it returns a void type, which means return nothing. So you can also document the return type. Yeah. All right. Let's go back here. So choose names, and then don't worry about if the name of the variables are long. That's just because you always use an IDE when you do Java development, and IDE just has the autocomplete feature, and you type the first few letters and then it automatically has the suggestion of what variable you're pointing to, and then you hit enter and that's it. So if I have a long name here, some names that are used inside the method, right? Now obviously I have to, so I just type SOME, and then the autocomplete tells me, oh, you probably, because we're inside the method, the scope of the method, obviously the suggestions mainly related to whatever is inside, and it has a L, which means you're probably referring to this local variable, right? So I can double click or just say SOME and enter dot length, right? So never shy away from writing long names in your source code. That's just because first of all, again, names don't matter in the bytecode, but then you're definitely using an IDE, and you're using the autocomplete feature. So you always type a few letters, SOME in this case, and then press enter, and the code is already written for you. All right. The name of a parameter must be unique in its scope, and this just doesn't apply to parameters of method. This is general, right? It can be the same as the name of another parameter for the same method or constructor, and it cannot be the name of a local variable within the method or constructor. We saw that if you have a field, so basically if I say int, or basically if I have the same declaration here. Now, first of all, var notation doesn't work for fields. You cannot have a field that says a string dot dot dot, because a string dot 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 is actually not a valid type. This is what the Java compiler does behind the scenes when you declare this as the type of a method, right? So var doesn't work. So var notation dot 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 does not work for fields of a class, right? Because it doesn't really define a type. And let's see what the compilation error is here. Syntax error, it just tells us a syntax error. So we want to declare it as a string array. All right. So this type, some names that, and this local, they have exactly the same type, right? And so if, but here, as you can see, when I'm in the scope of the method, local variables always shadow the global or class variables or fields, right? If you want to directly access this variable, the field, we can say this dot something, right? Now it tells me that we are referring to this basically field. Now the compilation error that we're getting here, first of all, we have to invoke the length, right? Yeah. And note that at this point the compiler doesn't realize that this array hasn't been initialized, so this is actually null. So if we don't initialize it somewhere, then this is going to give us a problem. That's why, again, the best practice is try to declare final. Then you end up with the compilation error that, hey, you never initialize this. So you have to initialize it in the constructor. But for now, if we don't do anything and directly invoke this, we are going to get a null pointer exception. That's just because that array reference is null, right? Null pointer exception, cannot read the array length because this dot some names that are used inside the method is null, right? So declare these as finals if you want to initialize them, and they are never changed, so that you can remove some of these unwanted null pointer exceptions, etc., right? So the point here is that local variables shadow the fields or global variables of a class. If you want to access the field that has the same name as a local variable, you use this pointer, right? Which means use the pointer that is pointing to this class, and this variable is going to be a field of this pointer, this object, okay? All right. A parameter can have the same name as one in class fields. If this is the case, the parameter is set to shadow the field. So local variables always shadow the global variables, and when we say global, because in Java there is no global scope, when we say global variables, it means the scope of a class, which means we're referring to the fields. Shadowing fields can make your code difficult to read and is conventionally used only within constructors and methods that set a particular field. So in constructor, it's now, first of all, there are different conventions that people follow. One is there is a convention which I don't personally encourage, is convention one is fields end with underscore. So for example, you say that let's say int x underscore, right? And then in the constructor you say that, let's say you say public var args, and then int x, and then you say that x, basically you declare the field int x underscore equals x. Now when you add underscore to and this is something that people, I would say, in Python or maybe C++ follow this convention, because then it's very easy to differentiate between local variables and member variables or fields, right? So this is one. Now the other convention is to maybe use underscore at the beginning, int underscore x, for example. That also works. Int let's say underscore x, and know that these two are valid. And again, then you don't need to in the constructor, you can easily differentiate between the global variables or the fields and then local variables. So we can say underscore x equals. And another convention that again that people follow, and again the thing here is that in C++ you can have global variables and you can have member variables. So what people do is the fields or member variables, they add a prefix m underscore to say that this is a member variables. And again, this doesn't really apply to Java, because if in C++, if you see a variable x, you don't know if it's a global variable or it's a variable that belongs to a class, right? So what people do, they explicitly add m underscore x to say that this m means member variable, and then you can say m underscore x, right? And again, this is something that usually people in Java don't follow, this kind of conventions, because it's just because Java has some restrictions that no variable can exist outside the scope of a class. So everything is a member variable, so there is no point, right? So int m underscore x. Now other conventions like using two double underscores, that's another thing. I think in Java people try to at least stick with single underscore. Two double underscore is a bit too much, right? So underscore and underscore, these also work. And then you can say x underscore underscore, for example, or underscore underscore x, something in that regard. But again, in Java the best practice is to use exactly the same name as the name that variables that are passed to the constructor. And obviously shadowing means if I say now x equals x, then both of them are referring to the local variables. This is the shadowing, right? And then the solution the Java provides is that you always have access to the this pointer, which means this.x, and then the Java compiler says, oh, okay, so you're pointing to x variable that is a member variable because you're pointing to the this object, right? So the best practice is use exactly the same name as the members, because then if somebody reads the looks at the documentation of your public constructor, they also know that, okay, probably there is a field with the name x that exists in the class itself, because this is the convention. So so the convention 3 use the same names, but use this dot something. So another convention is that for all the field variables or member variables, always use this everywhere. So but again, because if I'm in the basically in the scope of some method, I don't really need, if I say x, obviously as long as x is not a here x is a local variable, but let's change this to y, for example. And then if I say x, X works, I have to assign it, so int z equals x or 2x. This works, and I don't really need to say this.x because there is no confusion for the compiler. But one of the conventions that some people follow is always use this. So this is really not necessary, but this explicitly avoids the problem of shadowing, because even if there is an x variable in this scope, then you are guaranteed that this x refers to the object. So another convention that some people follow is always use x, this dot notation everywhere in the class. I mean, that's a little bit of not necessary, but that's another convention, right? And I would say none of these conventions are the best practices. It's just convention means it's a matter of style. It's not really part of the best practice, and different people usually stick to the same best practices, but then follow their own conventions, or any convention that is easier for them, right? Now we see if I added the parameter that takes an argument, I have no access to the no-arg constructor anymore, but we can, for example, add it explicitly here, public var args that takes no parameter, this.x equals 1. So we initialize with 1. Everything works fine now. All right. So shadowing happens. Use the this. For example, consider the following circuit class and its set origin method. So we have a circuit class. It has only a default constructor, private int xy radius, set origin in x in y. So obviously x and y are local variables, or local variables inside the scope of this method. So you cannot directly, if you type x, for example, here, it always refers to the local variable. So it shadows the global variable or the member variable or the field that is x and part of the state of the class. And the way you tell the compiler, hey, I want to actually use this field x, you have to use the this in this case. So that's the only solution at the moment. That's why people prefer, again, x underscore y underscore. They prefer to add some sort of underscore at the end for the fields or member variables, or say m underscore x, m underscore y, m underscore radius. These are the conventions. So my suggestion is to just take one convention and stick to it. My personal convention is to not use any of these dot underscores or m underscore, because these are really not Java style. And I just use exactly the same names, and whenever there is ambiguity for a compiler, I use this. If there is no ambiguity, I just directly use the name, right? So that's my convention. The circuit class has 3 fields, x, y, and radius. The set origin method has 2 parameters, each of which has the same name as the one of the fields. Each method parameter shadows the field that shares its name. So using the simple names x and y within the body of the method refers to the parameter. It refers to the local variable of the method, not the field. To access the field, you must use a qualified name. This will be discussed later in this lesson in the section titled using the this keyword. Again, if you want to tell Java, hey, access a member variable or a field, you have to use the dot operator. And whenever you're inside the class scope itself, you haven't created an instance of the class. So how do we access the member explicitly? We use the this pointer. This means whenever an instance is created, use the pointer that points to that instance in the memory, right? So this is just a general pointer whenever you are inside the scope of the class and you want to access any of the member variables. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.